here we have a polynomial. We're going to try to find all the zeros. So thinking of the rational zeros theorem, you know that it tells you here that there's at least one rational zero, so that you know that you're not on a blind search for one of these when you start. So we could take factors of the last number over factors of the first number. So what I would like to do usually is keep that in mind. So I could have like 9 over 4 or 1 over 4 or 3 over 4 or 9 over 1, 3 over 1, 1 over 1. So keep those in mind and then graph this function and see what it looks like, because that way you can check and see that before you start doing any synthetic division that you're only going to do numbers that actually work. And so the graph of this looks something like and you can use any you can find, but they're usually easier to kind of eyeball, and then you can check on your calculator too if those values actually give you 0. If you can find one that's a nice whole number, so when you graph it and you're on your calculator, it looks like this crosses at x equals 3. So what's a good way to tell if 3 is really a 0 of this? Well, if 3 is a 0, I should be able to synthetic divide or do synthetic division, because if 3 is a 0, I know this is a factor. So all you need to do is get started, and picture this is degree 3. Once I do one division, I'll be down to degree 2, which is quadratic, and then I could use quadratic formula, or I could factor it, whatever I can find that works. Alright, so this is 4x to the third minus 16, 9, and 9. So add, multiply, add, multiply. So add, multiply by 3, add, multiply by 3, add, multiply by 3. And it looks like, oh, I got a remainder of 0, so that was a 0. So why is that useful? Because we just factored out this factor, and picture what we're left with now. This says 4x squared minus 4x minus 3. So it's all one less than degree than before. So we already have 1 0 from here. Now we could try to factor this, and if it doesn't factor, we could use quadratic formula. And I think this one factors. You can use AC method if you want to. If you think you can guess and check it, that's fine also. I think this one is 2x and 2x. Then what would multiply to negative 3? I could do plus 1 and minus 3. And then check and make sure it works, so FOIL it. First, my inside term is 2x and negative 6x is my outside. That adds to negative 4. And it multiplies to negative 3. So now I have it factored completely. It's much easier to tell you what zeros there are. Make some room here. So it looks like from here I get 3 is a 0. So that was the first one I found to kind of open up the whole thing or have something to divide by. And then negative 1/2. And then add 3 divided by 2 and positive 3/2. So if you can find 1 or 2 zeros, then synthetic division makes your equation smaller every time, and it makes it easier to find the remaining ones. And I can check 1 1/2, negative 1/2 actually look like zeros on my graph.